Hello, I'm Anna Mackay, and in this video we're looking at logarithms in base A as opposed to the last video where we were looking at logarithms in base 10. For example, to find log base 2 8 or log of 8 base 2, we ask what power must 2 be raised to in order to obtain 8. And so we know that, as we said, 2 must be raised to. So if 2 to the power of 3 is equal to 8, then here is our equivalent. As I was talking about in the last video, a little flowchart that I like to think of is if we have base 2 to the power of 3 is equal to that number sitting next to the log 8. So a little flowchart. So here's this rule for that if you have base A to the power of C is equal to B. So base A to the power of C is equal to B. And that's how that example that we had on the previous slide can be written. These are equivalent statements. And looking back at the previous video of base 10, so let's look at the similarities here. Here we have log and we define the base of A, whereas when we can't see a base, it's that base 10. That's maths convention that if you can't see a number down there, it's base 10. And so base 10 to the power of B is equal to that A. There we have that base 10 to the power of B is equal to A. Doing some examples here, we're asked to write an equivalent exponential statement. So we're talking about using powers, so no logs. So the little flowchart, 10 to the power of 3 is equal to 1,000. So we'll write that 10 to the power of 3 is equal to 1,000. And that's our answer for this first one. Next, now it's a different base. We have base 5 to the power of 2 is equal to 25. So I'm going to write 5 to the power of 2 is equal to 25. And that's fact. We know that that's true. Next one here, what if we have to write the logarithmic statement? So let's do that. We have log. Now, the base number sits next as like a subscript for the log. So the base is 3. It's going to be equal to the power of 4. And therefore 81 sits there with the log. So the log of 81 in base 3 is 4. This example here, finding log of 16 base 2. Let's transform 16 into a base of 2 and a power of something. And that would be log base 2 is 2 to the power of what? 4. And therefore our answer to that is 4. We did some work on that with logs of the rules and in the previous video. What about this one? If we can write it base 5, so 0.2 is the same as 1/5. And now let's write that instead of 1 on 5, let's do it 5 to the power of -1. So therefore our answer for this is 5 raised to the power of what gives you this answer here. So it must be -1. Next, here we have log of base 10. Let's write that 100. Not only shall we make 110 squared, let's take that fifth root and make it 1/5 and tidy this up a little. So essentially what we're saying is 10 raised to the power of what number gives you this, and therefore we read off the power and our answer is 2/5. Example D. Let's transform that 1 on root 2 and make it 2 to the power of -1/2. And therefore our answer, because we've got base 2 here and base 2 here, we can read off the power of -1/2. And we're ascertaining the rule here from the work that we're doing. If you have log of base A, and here is your base A again, then the power there is also your answer for all real values of x. And this one here, solving for x. So the little flowchart works like this. We have 3 to the power of 5 is equal to x. And we know that x is equal, hopefully you might know that, 243 for 3 to the power of 5. Join me for the next video, Laws of Logarithms. Thank you.